Testing. User interface. Streaming setup. Let's see if we how are we doing. We have camera, Acorn Atom, chat. Nice. Acorn Atom theory and practice, and this is what I primarily use to learn programming. This setup here back in 1980. Byte vectors using question mark, sorting algorithm, arrays, and of course assembly programming. Three-dimensional plotting. I remember typing this one in. It was like magic. I didn't understand how it worked. 3D plot. So let's move this here a little bit and I can see out just a touch. And I'm going to type in this listing. Get this set up. How about I do that? Yeah, alright. Well, anyway, let's type this in from the original book. 1. 3-dimensional. I don't need to put the comment in. 5. L equals 30 semicolon. M equals 40. N equals 8. Line 110. Z equals Z equals 0. No, I'm going to put the monitor down here. Right, Z equals 0. M, don't do caps, ready capitals. Right. So this is so old technology that that's a capital. Those are capital letters. These are lowercase. It would show the lowercase in reverse. Because then the video chip would need to have so much space for the fonts. It's literally that. Anyway, Z equals 0. Clear 4. I remember clear 4. Get into the high resolution graphics mode. 120. A is equal to hash 8000. That's hexadecimal, so this is fantastic. I mean, this is 1980. The Atom Basic had hexadecimal right there where you need it. Hexadecimal. B, I was like 15 at the time. B, no internet. Oh, I had caps lock on. B equals hash 9800. I wonder what those are for. We'll find out maybe. Right, 130. For J, can't type too fast. It doesn't have 2-key rollover. If you hold down 2 buttons at the same time, or as you type, you hold down button and you press the second button before you release the first. Modern keyboards handle that. It's called 2-key rollover. Acorn Atom didn't have 2-key rollover, so you've got to lift your finger up before you press the next key down. So 4J equals A to B. Step 4, semicolon, exclamation mark J. The exclamation mark in Atom Basic means the address of. So this is actually a pointer. So this was fantastic about it, because it's like all the fundamentals of software engineering right there with pointers. Of course, you didn't have to use pointers. You could just stick with pure BASIC, but what was great is that you could interleave BASIC and sort of hardware operations. Basically what it's going to be doing is writing directly into memory between addresses 8000 and 9800, probably to clear the memory. In fact, it's going to make the screen white. I can see that, because this is going to do, the address at J, which is in a for loop between 8000 and 9800, is going to be set to -1. And the lovely thing about -1 is n dot is next. It's short for next, so I'll write it out, next. Wonderful thing. Right there, 1980. Learning about number systems in binary. Yes, -1 is all the bits set. In the two's complement number system, which is the only one that is really used by any computers that survive this day. I could go on about things like bit operations on signed integers being undefined operations according to the C standard. We'll leave that for another day. So, okay, that should... Well, we can try running it. Let's just try running this and see what happens. Error, line 55. Why? What's wrong with line 55? So in line 55, m equals 4 minus. It should be 40. So now comes the wonderful editing facilities of the Acorn Atom. Funny thing is, I've started using it again, and I actually like it. But I'm not sure whether it's nostalgia or not. You see, I want to redo line 55, so I could just type in line 55. But why do that when it's on the screen? You can use the cursor keys here. There's only two. There's up and down and left and right. You use shift to go in the other direction, right? So if I press this is up. If I press this with shift, it's down. So I can go up to 55. I spent so many hours programming this, it seems like yesterday, you know. And copy, the copy key. And when you press copy, it's copying those characters on the screen. It's not printing them out. But it is actually as if I was typing them in. And so we go up until we get to the error there, which was a dash instead of a 0. And we go 0. And then I'll copy to the end of the line. And there's a repeat key if you want to repeat. I mean, you're used to these days, your keyboard does an auto repeat. This didn't have an auto repeat. It had a button for repeat. It's this one here. So anyway, I've done that and I hit enter. Now I'm up there. If I type, I'm typing over this stuff. So, you know, I'll just come back down here. And then it's always good to make sure that that edit worked properly. So we could just say list. I can list the whole thing. Or I could just list 55. Or I could just do L dot for short. L dot 55. See, it's fixed. Now I'm going to run it. Run. And, whoa, let's try that again. Run. You might have noticed it flashed white for a moment. That's because it actually worked. But a peculiarity of Atom Basic is that you need to put the end command at the end. If you don't put the end command at the end, it treats it as an error. And when it reached the error, it reverted back to normal mode instead of graphics mode, so you could see what's going on. You could see the message. That makes sense. So then what are all those ats on the screen? Well, if you put 0 into memory, into the video memory, that's the character that you get, the at symbol. So that's why we've got a whole bunch of ats. Well, let's just do a little list here. And 999, that was the old traditional thing. End. I'll try running now. And it still doesn't work. So let's do L dot and list. What's the problem with line 130? Oh, the flash was just to change it to clear 4 for the graphics memory. So it doesn't... What does it not like? Oh, I have a double S. That's because this keyboard is 40 years old and it hasn't been used for some time, and sometimes the keys bounce. So that's no problem. We'll just go and do our little copy thing, won't we? We can go up here like that. We're going to hold down the repeat button and do copy until we get to one of the S's. I copy that S, I move the cursor without copying, and then copy the rest of the line. Oh, I remember all these incantations. Right, L dot, there we list. That seems to have fixed it. So let's try this again. Run. It still does not like line 130. And I suspect the reason it doesn't like it is that I need some spaces. Let's have a look how it was written out. For J equal the A to B step, these needed spaces. So A, and now I hit space. Oh, but then my thing went away. Right, so how do you insert a character? Okay, now I need to insert a T. So shift back, and then I can do the T, and then copy, and then shift back, space, and then copy, and then shift space, copy, and then copy. It's all right. Makes sense to me. Where did 40 years go? 42 years go? 43 years go? 43 now. Yeah, so you fix the line. That's fine. And run. Aha! That's better. So what? Well, I'm just going to hit break, and then it's like, oh, I've lost my program. You can run the command old. Will recover the program that's still in memory. L dot. Yeah, that's clearing the screen, and you see it's a bit slow clearing the screen. How much memory is that clearing? We have, well, from 8,000 to 9,800 or 1,800 in hex, which is going to be, well, one block of 256 bytes is basically 100. So if you have 16 256 bytes, that's 1,000 in hex. That's 4K. Is that right? Yeah, that's 4K. So in this case, it's 4K and 2K. It's like from 1,800. So it's a block of 1,000, then plus half a block of 1,000 or 800. And so that is actually 6K, which is all of the graphics memory. So this is 6K of graphics memory. Way to go with that. Yeah, that's what 6K of graphics memory looks like. Oh, old. What 6K of graphics memory looks like. Okay, so maybe I can hit escape. Oh, look, and it comes back. That's good. Let's continue typing this in. So we're at line 150. Line 150 is S equals L times L, which it shows as a star rather than an asterisk. But it's a star. It's a lovely star on the key. It's always a little confusing that, but anyway, L times L plus M times N. No, don't do it. Capitalize it. Right, M times M, and we need a plus. Let's try that again. So L plus L. No, L times L plus M times M. M times M. Right, there we go. So it's calculating the square of L plus M, where L was set to some initial value on line 50, and then it does GOS full stop. That's abbreviation for go sub, or go to subroutine. And there was this weird thing that in order to do a label for a go-to, you could use a lowercase letter, which of course here appears as a reverse character. In the manual they're written as lowercase, so there's a lowercase s, which appears on the screen like that. So that is go to that subroutine, which hasn't been done yet. And then semicolon S equals L times L plus M times M. Right, how's that? L times L plus M times M, that's what S is. It's setting it twice. Oh, I'm reading from the wrong line. We're on line 150. It's just R equal Q. Okay, that's line 150. And we're going to do line 160, and yeah, line 160. S equals S plus N times N go sub S, and now we do S equals L times L plus M times M. 170 T equals L times L plus M times M plus N times N. That looks like it's doing a three-dimensional distance calculation, or square of distance. I wonder if there's a square root in there anywhere. Oh, no, line 4. Yes, there was no square root. There was no floating point library, so you have to calculate your own square root, which is on line 400. That's go sub S is the square root function. So what fun! So line 70 is going L times L M and N times N, adding it together. And the camera just died. This camera is annoying me because the battery dies. When I'm streaming, I need to figure out why on earth it does that. It really shouldn't, but anyway. So it's a test. That's what this is all about here. So what we'll have then is L times L plus M times M plus N times N, where L, M and N are the coordinates of a three-dimensional vector, and that's T becomes the square of that length of that vector. So we've got that, and it's like 200 FU. I don't understand what that means. Oh, it's short for 4. 4, yes. For U equals minus 20 to 20. Right, line 210. V equals minus 20. Go sub C, and then go sub B. B, C and B. Okay, and then we do 220 for V equals minus 19 to 20. Do the abbreviations now. Go sub C, go sub A. Next. 230 end. Guess we don't need my 999 anymore. Let's try listing that, see what we've got. I'm going to compare it. So as L equals 30, M equals 40, N equals 8, Z equals 0, clear 4, A equals 8,000 hex, B equals 9,800 hex, 4J equal A to B. Step 4, set address J to -1. Next, line 150, S equals L squared plus M squared. Go to the subroutine for the square root and put the result in R, because I think Q is the result of the square root, so it puts the result of the square. So that's the length of vector LM. Line 160, S is equal S plus, so we have a change in the value of S. S plus N squared, that is what it says here, and then does a square root calculation and then sets S equal to L plus M. So what's happening is it's calculating a square root of another offset vector, or another point which is offset from the first one, and then I think it just sets S back to where it was. That's on line 160. It's the same thing that was on 9150. So basically it's calculating a couple of distances and then resetting S back to where it was. A bit weird, but T equals L. Alright, so then it's T equals the square length of the three-dimensional vector LMNN, and then for U equals minus 20 to 20. So I think this is where it begins doing the plotting. In fact, there are two for loops nested, because it's going to do a three-dimensional plot, so it's going to go through the X and Z or whatever, you know, then plot the vertical up. So that would be V equals minus, for U equals minus 20 to 20, V equals minus 20, then go sub to routine C, go sub to routine B, for V equals minus 19 to 20, go sub C, go sub A, next, and then end. So if we try and run this now, we will get an error 157 at line 230. That's interesting because 230 is at the end. Ah, yes, that's what was confusing. It's because it can't find the subroutine. But there wasn't much memory in these things, so like error messages were not. You couldn't waste EEPROM or ROM memory on silly little error messages. So, but anyway, 400. The problem actually is that we need our subroutine for calculating a square root. So there's the label for this, which was the lowercase s, which appears as a reverse s here. Q equals s divided by 2. So looking at it, it's using the successive approximation algorithm, which is not the best one. And I found out years later that I really should have been better. It would have been better if I had been using Newton's method. That I always use this method, and the reason why I always use this method was because that's what I learnt in the book on page 83 here. There was no internet. There was no chat GPT. I could go and ask, dear chat GPT, what's the best way to calculate the square root? All I had was page 83 of this manual. Anyway, we go here and do is this a do while loop? Until, it's a do until, yes, it's abbreviated everything. So do Q equals Q maybe it is Newton's method. Was my father who taught me the successive approximation method? I don't know. I think this is Newton's method. C section. I wasn't paying attention. The clues were there. 522. Section 522. Curious. That's section 522. 3. Yeah, my father taught me that. I used to calculate the square root using that by hand on my calculator. 522. Successive approximation. Square root. There's a square root function. There is a square root function on page 35. Do until, especially useful for problems involving successive approximation where the value of a function is calculated by obtaining a better and better approximation until some criterion is met. I wasn't paying. No, I didn't. If I had paid better attention to the book, but I was stuck with my memory. My father taught me. Ah, interesting history. So anyway, we'll continue. So do Q equal S over 2. No, S over 2. Yeah, dividing a subroutine by 2, you can't do that. Actually, Q equals, let me do that line, Q plus S divided by Q divided by 2. Divided by Q divided by 2. So that's Q equal Q plus S divided by Q divided by 2. Okay, and now we need 415. 415. Again, 415. And that's going to be until. And so the stopping condition here, that's clumsy. Oh my word. Q minus 1. Double key bounce there. Until Q minus 1 times Q minus 1 right, so until the result minus 1 is less than the number we want, and the result plus 1 squared is bigger than the number that we want. Yes, okay. S and Q plus 1 times Q plus 1 is greater than S. 415 and then 420 return. So I could actually just test this out right now. What I need to do is put the value that I'm trying to calculate the square root of in S, and I get the resulting Q. So let's just see if this works. If I put S is equal 9 and then I go sub S, we get an error. Of course we do. Line 400. Let's list. It looks alright to me. That's 400 S. Q equals S divided by 2. Then we have do Q equal Q plus S divided by Q divided by 2 until less than Q, yeah, and then return. Let's try by line number. I can say go sub 400. It says error 152. We need to debug this now. How do we debug it? We don't have a debugger. What I'm going to do is put line 405 and return. So now if we, and this is still a debugging technique that I use in the modern context. It's like, okay, I have, well, it's in effect a function, line 400. It's going to jump to line 400. It should just return. Let's just see if that works. Go sub 400. And it says error 152. And so then we have to figure this out. So, what am I missing? Error 31. That's a different one. It's probably the same as that. So yeah, return it. You write return completely. It's like it's not ret, right? So I'm going to try an experiment on some other random, like line 800. I'm going to have return. So I should be able to do GOS 800. That doesn't like it. Maybe I can't use... I don't remember if I can use line numbers for Go subs. Maybe I can't. I have a nagging doubt about that. Let's see. U. Return. Surely I should be able to do Go sub U. Error 152. Now, I don't understand what's going on there, so time to look for the error messages. Errors. Dear me. The great thing about this, though, is I sure learned about programming. Errors. Where is there a list of them? Error codes. Error codes 205. Time for the old error code. 205 is the 205. No, 152. The page was 205. 152. Go sub without return, or for without next. The go sub statement, when used in direct mode, must be followed by a semicolon. Example: go sub 10. In direct mode, must be followed by a semicolon. That's weird. This I do not remember. But if I understand this... Oh, did we have a line 80? I'll have deleted a line 80 if there was a line 80. I don't think so. Go sub 800. And then we get error 94. Unknown command. Invalid statement terminator or missing end. Uh, 800 U. What I don't get is what this thing that it was saying about the semicolon. Surely not. Go sub U. This is annoying. Right. Maybe I need to have some kind of statement in there. Let's do print hello. Go to 800. See, that worked. And if I put 810, I can put an end on there. And so I could go to 800. That worked. Though I will see if it prints. So that I'll see whether it actually tries to execute the thing. Go sub 800. Just 152. Go sub. Copy, copy, copy. Go back. Shift U. Copy, 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 copy. So I've created a label. For line 800. I should be able to just go to the label. Yes, that worked. 810. I put a return statement in. Go to U. Error 31 because I have an invalid return statement. But if I do a go sub to it, go sub U. That is very odd. Go sub without return. This is very, very odd. That's bringing back memories indeed. What am I doing wrong? If I list this out, could it be something to do with... Oh, I'm looking at 400, lowercase s, and q equals s divided by 2. 405 space r dot. Maybe it's because I'm trying to run go sub from directly from... Oh, maybe it's that. Oh, yeah, I'm not allowed to do that because it will be... What's it going to return from? A function from the command line. I don't think you can. But I think the test for this would be... I don't have anything before line 55, so if I do line 10, go sub s, we'll see line 20 end. If I run this, okay, I understand now. I can't run subroutines from, well, there's something about direct mode. Oh, maybe what it meant was if I do go sub s, I get this error. If I say go sub s semicolon and then do something else, okay, so you can run it in the immediate mode, but you need to follow it with the semicolon. Yeah, because it needs somewhere to return to. I can understand why that, but in the end it's saving memory, you see, preventing bloat, because there isn't much memory. A whole machine has got 6k of RAM and 6k of video RAM and probably 4k of ROM. Right, so where were we? I was trying to test the square root function out, so I'm going to set s equals, no, not that, s equals 9, and then we do go sub s semicolon, and then we print the results, which would be q 4. I'm not entirely convinced with that result. The square root of 9 is not 4. I wonder, is this a limitation of the thing? Because there isn't floating point. There's only integer arithmetic on this thing. I mean, it's not going to have floating point. So let's try something. 77 times 77. Right. I'm going to set s equals 77 times 70 equals 77 times 77. There we go. And then we're going to do the go sub. I can just come up here and copy that. There we are. Do that. And then print q. So the square root. That's no way that's right. That's not the square root of, so there's a bug. The square root function is really not working as a square root function, but that's what allegedly it's trying to do. Let's read. Oh, it's divide. Oh, see, it's all the same issues that you get with modern programming right here. This is the classic one. You put in debug code and you forget you put it in, and then my square root function is dividing the number by 2 as an integer. 9 divided by 2 is 4.5, but it gets rounded down, so that's why we had a 4. All I need to do to fix this is remove line 405. I think that deleted that. Oh dear. Right. And now let's try this again. So we're going to say S is equal 9, and we do go sub our square root function, semicolon, and then we're going to print the result. 3. The square root of 9 is 3. This is good. So I think our square root function is now working. Let's carry on with the listing. So only a few more lines. We've got another, because that's a function, a subroutine that calculates the square root, integer square root. And the next one is a subroutine that draws from, it's actually plotting the curve by the looks of it. So let's do this. 500 is a rem, draw to, right, I don't need that. 510, we put the label A, Z equals 3, and then 520, you put label B, O equals T minus U, O equal T minus U times L minus V times M minus W times N. Just check that. O, T, yeah, that. Yeah, that looks correct. And then we'll do 530, one line 530. We have C equals T times V times L minus V times M minus W times N just read that back. C equals T times open parenthesis V times L minus that's for line 53. I don't like this. Let's go back. See, it's not 530. Hit escape. Oh no, that does that. Right. Copy 530 and then C, and then copy equals T times V times L minus U times M times M, close parenthesis, I was copying the wrong line, times 4 divided by open parenthesis R times O close parenthesis plus 128. So let's list that line 530 and check. C equals T times V times L minus U times N times 4 divided by R times O plus 128, except I ended up with the key bounce, which has given me 2 of these. So let's skip one and copy the rest of the line. List 530. C, let's check again. C equal T times V times L minus U times N times 4 divided by O. Yeah, okay. Right, next line, 540, is going to be D equals 96 plus 3 times Q times open parenthesis W times S minus N times n times open parenthesis u times L plus v times m r times o. Right, let's check that. Line 5, 6, what happened to it? Line 40, 540, right. D equals 96 plus 3 times Q times open parenthesis W times S minus N times open parenthesis U times L plus V times N close parenthesis divided by R times O. And we then find, nearly there, line 560, plot a line from Z plus 4 so we plot Z plus 4 comma C comma D. When you had functions, you had to, an expression and an argument, you'd have to put parentheses around it. Is that an O or a 0? It's a 0. And then return. So that is plot Z plus 4 CD Z equals 0 return. And now there's one last line, which is a subroutine called C, which is going to be W equals 300 divided by 10 plus U times U plus V times V minus 10 minus, I hit escape. Let's copy that. So we got as far as the minus 10 and yep, I saw there if I do list comma 100 I have, so that's list up to line 100. What? List dash 100, list 0 comma 100. Oh, that's how you do it. Okay, I need to get rid of line 10. I need to get rid of line 20. That's the that's the program, and of course you can't see it on the screen all at once, so we just do a list from 0 to line 399. And then we can check that. So L equal 30, M equal 40, N equal 8, Z equals 0, clear 4, 8,000, 9,800. It's good to check. There's a reason. It's like if you make a mistake and it overwrites memory, it can overwrite what you just typed in. So you learn to double check your work. 4J equal A to B, step 4, minus J equal minus 1. Next, S equal L times L plus M times N plus go sub S, R equal Q, S equal S plus M times N, go sub S, S equal L times L plus M times N. Line 170, T equal L times L plus M times N plus N times N. There's not really much chance that it would overwrite it. It's only the thing that clears the screen that would, but I'm still checking it. 4U equal minus 20 to 20, V equals minus 20, go sub C, go sub B. 4, V equal minus 19 to 20, go sub C, go sub A. Next, next, end. And then if we list 400 to 499, That's the square root routine, which we already checked and worked, and then I can go from 500 onwards. A, Z equal 3, B, O. Yes, I can see O is a fatter circle than the 0 in the font here on the page. So that's, and obviously you don't assign to 0. O equal T minus U times L minus V times M minus W times N. T, C equals T times V L minus UM times 4 divided by RO plus 128. D equals 96 plus 3Q times WS minus N UL plus VM and divided by R times O. Line 560, plot Z plus 4, comma C, comma D. Z equals 0, return, and 800. Oh, right, that isn't part of the... That was debugging. Let's try it. Look at it racing. Crazy fast, isn't it? That gives me time to fix this camera. Or at least turn it on for a bit. I remember this. You type it in and you had to be patient as you waited for it to do its thing. So to start streaming, unplug and if you put it in streaming mode, dear me. So let's try. Yeah, you know, it's the thing. This camera doesn't. Its user interface. It's not much better than the Acorn Atom. Right, and then this. You can plug this in. It should be able to charge via the stay charged via the USB. Otherwise, what's the point of having it able to stream? That's just insane. Anyway, if I come over here, I should be able to. Oh, it finished already. Wow! See how quick time flies when you're wrestling with technology. Properties, and then deactivate and then reactivate, because of course it can't do it itself. Ta-da! Alright, so that's working now. The battery is low. There we have it. We have a graph on the Acorn Atom. Wow. I remember typing that in 43 years ago. Plenty to look at in here. So what I'm thinking of doing is just doing a course of programming using the Acorn Atom. Why not? Think there isn't anything that you can learn from 43-year-old technology? Oh. You learn a lot. In fact, you learn a lot about how much we've forgotten. Until next time. This ends